Today we're going to be talking about writing exponential functions. The very first thing that you need to remember is that exponential functions are curves. The curves are either going to grow or move in the upwards direction, or they are going to decay or move in the negative direction. To know if they are going to grow or decay based on the equation, you have the equation of f of x equals a times b to the x power. So if b is greater than 1, then the exponential function is going to represent growth. If b is less than 1, the function represents exponential decay. So let's look at some of the information that you would see given to you to determine whether it's going to be growth or decay. As an independent variable in an exponential function changes by a constant amount, the dependent variable is multiplied by a constant factor. This means that the constant y values form a constant ratio. Think about geometric sequences. If you look at this table here, they start with 0, 1, 2, and 3. Those are the locations on the graph. And your y values are the associations of each. Now, when you look at 2, 4, 8, and 16, you'll notice that those things are growing. And they are growing by a constant value. If you want to find the constant value, just like we did geometric sequences, you say 2 times a number is going to give you 4. Well, 2 times 2 equals 4. If it's constant, it has to be the same number. So let's check. 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. That is the common ratio that we have. Now, to write a new exponential equation, you have to use the formula f of x equals a times b to the x power. Remembering that if your b value is greater than 1, you're showing growth. And if it is less than 1, you are showing decay. Now we are going to use an oldie but goodie and put a little bit of a twist on it. And in order to find our new exponential equations, we're going to use a regression formula. The regression formula for exponentials is y1 tilde a times b to the x1 power. So remember that when we see a table on our next page. Let's look at example number 1. It says the table contains some points on the graph of an exponential function. In order to write a function that represents the same relationship, we need to follow a few steps. In Desmos, what I want you to do is I want you to first create a table, then enter the information, then put in your regression formula, which is y1 squiggly a times b to the x1 power. All right, let's do it together. We have to add a table, enter the information that they provided. So 0 is paired with 0.25, 1 is paired with 0.5, 2 is paired with 1, and 3 is paired with 2. After that, we're going to put in y1 squiggly a times b close parentheses raised to the x1 power. Now remember that you are putting your y1 and your x1 at the end. That's going to create a graph for you, but I don't really care about any of that information because all I need to remember is that my formula is going to be y is equal to a times b to the x1 power. Now over here on my Desmos, it told me that my a value is equal to 0.25 and that my b value is equal to 2. I'm going to take that information and I am going to write my new equation. So I have y is equal to 0.25 times 2 to the x power. Now I know I really quickly on that, so let's try again with example number 2. You are going to take the information that you find in the table, you're going to enter it into Desmos, and then you're going to find your A and your B value. I am going to give you a little bit of time to do that. Come back and check your answers in a moment. All right, how did you do? You should have gotten A is equal to 15 and B is equal to 0.833333, which when you convert it to a fraction is 5/6. So when I rewrote it in my final answer, I put that y is equal to 15 times 5/6 to the x power. Now sometimes you're not given a table, sometimes you're given a graph. So let's look at example number 3. It says an exponential function is graphed on the grid. Write a function that represents the graph. What you have to do is to create a table from the data that it provides for you. So what we want to do is first draw our table, knowing we have x and y values, and then we're going to have at least 2 good points. Good points go through the corner of a box, and I would prefer they be whole numbers. So let's see where -1 crosses. It crosses at -1 and 45. So I'm going to put a dot right there, and I'm going to put that into my table, -1 and 45. And then I'm going to go to 0 and 15. That is going to be my y-intercept, 0 and 15. And you can also do 1 and 5. 1 and 5. From here, we're going to put in our regression formula, which is y1 squiggly a times b to the x1 power. And we're looking for our a value and our b value. So let's go ahead and pull up Desmos, put in the information, -1, 45, 0 and 15, and 1 and 5. Then put in your regression formula. And then get your A and your B value. My A value, it shows, is going to be 15. And my B value is 0.333 repeating. Now I want to change that 0.333 repeating into a fraction. So over here I'm going to put in the letter B again. It rewrites my number for me, and then I'm going to hit the little fraction bar, and it changes it into 1/3. So now my new equation is y is equal to a times b to the x power, where my y is equal to 15 times 1/3 to the x power. Now I'm going to pause right here so that you can do number 4. Remember that you need at least 2 good points, but I prefer that you get 3. I would select this point, and this point. I'm going to pause my video, come back when you have it completed. All right, this is what you should have gotten. A is equal to 4,000, B is equal to 2, which makes our equation y equals 4,000 times 2 to the x power. If you have any questions about any of the things that you did today, please let me know. I'll be happy to help.